rates in calculus, we're talking about problems that involve maybe more than just a y and an x, where you just have dy by dx. You have more variables and therefore more derivatives to consider. The derivatives are related, however, they're related by the chain rule. And so what we can say is every problem in calculus with related rates is usually a word problem, a story problem that makes use of the chain rule. Related rates problems are applications of the chain rule. So the first thing to identify is what those basic variables are. So when you read a problem, a word problem, you have to identify what those quantities are, the basic quantities. What depends on what? What is the independent variable? And what depends on that? Usually, not always, time is the independent variable. We can give examples also that do not involve time at all, but if time is present, then often it is the independent variable. In trying to decide what the basic quantities are, don't worry about the derivatives yet, because as soon as you list the sequence of variables, y depends on u depends on x, something like that, then the derivatives will appear at the very next step when you write down the chain rule. So you don't need to put them as your basic quantities. So let's take a look at the setup from the chain rule, which we'll have to review first off. So we begin with a review of the chain rule. We start with very generic quantities, y depending on x, but we have an intermediate variable u here, u depending on x and y depending on u, so that indirectly y depends on x. In this setting, the chain rule says dy by dx is dy by du times du by dx. That's the chain rule in differential form. You can justify, or you can look at it and remember at least how the formula works by imagining that you could cancel the du's and get this equality. The justification is not something you have to worry about. We're just going to go ahead and use it. Before you can use this, you have to learn how to set up the problem. Related rates problems are word problems. You'll be given some description that involves some quantities, and you'll identify what the relevant variables are that go in this chain. Some advice is students often look at what's given in the problem, and the problem might make reference to the derivatives, probably will make reference to derivatives, but don't include these derivatives in your original list. So when you're identifying the variables, hold off on the derivatives. They will appear at the next line when you write down the chain rule. Also, when you try to decide what your variables are, what depends on what, it requires some thought, of course. Often time is the independent variable. If time appears, it usually will be the independent variable, often, not always. Some problems do not even involve time. And so we'll see examples of those as well. Getting the variables listed in a natural order is a good start. If you switch around two of the quantities, then that means that the arrow becomes reversed there, and so if u is naturally expressed in terms of x, then writing it in the other order, the relationship may not be as natural. It may require some inverse functions, something like inverse trig radicals, like square and cube roots, and that will make your job much more difficult. In principle, you could be able to solve the problem with more than one way of listing the variables, but we'll see an example that shows that you can actually do it in more than one way and still get the right answer if you're careful. Now, I'll remind you, whenever we talk about the chain rule, You can't just talk about the derivative of a variable unless you say with respect to what. For example, what's the derivative of y? In the chain rule, there are two derivatives of y that appear. One is the derivative with respect to x, and the other is the derivative with respect to u. They're, of course, not the same thing. That's why we have to multiply by this. Although they're not the same derivative, they are related. They're related exactly by the chain rule. So when we talk about related rates, it's the derivatives, at least three derivatives that we're relating together by the chain rule. Now we'll need some experience doing problems just to see how to set them up, getting experience with looking at the problem that's given to identify what the variables are, what information is given. Typically, in the end, you're going to be given all but one of these derivatives can be either given or found by taking a derivative algebraically, and then you'll be left to solve for the other. It might be this one, or this one, or this one that you have to solve for. So we turn now to some examples.